The gate control theory of pain explains how pain works with the body. But first, to understand this theory, you have to know how nerves work. Nerves are made up of a bunch of different fibers that transmit many different signals and sensations to the brain. Two kinds of signals are released when we feel pain. The pain signals are carried by small nerve fibers, and the sensory signals, touch, temperature, and vibration, are carried by large nerve fibers. When you injure yourself, the body stimulates pain receptors, which releases chemicals. The signals travel through the peripheral nerves and up to the spinal cord. But before the signals can make it to our brain, the gate control theory comes into play. The gate control theory suggests that these signals, when they're on their way to the brain, encounter these neurological gates at the level of the spinal cord. These signals can only reach the brain if the gates let them through. This diagram represents the gate control theory. You can see that the S represents small fibers carrying pain signals, while the L represents large fibers carrying non-pain signals. The I is the inhibitory neuron, which pretty much act as the gate. The P is the projection cells, which are the pathway to the brain. When no input comes in, the inhibitory neuron stops the projection cells from sending any signals to the brain, and so the gate is closed. When there's normal sensation, there's a greater amount of large fiber input than small fiber input. So the inhibitory neuron again blocks the projection cells from sending any signals to the brain, and the gate is closed. When there is pain reception, that means there is a greater amount of small fiber input, or there only is small fiber input. This inactivates the inhibitory neuron, which makes the projection cells free to send signals to the brain, informing there is pain. The gate is then open. This theory has taught us a lot about how people feel pain differently than others, and how we can control our pain. For example, people who are born without the sense of pain have a condition called congenital insensitivity to pain. These are people who lack small nerve fibers, and so their gates are always closed and they can never feel pain.
Now, it might seem really cool to live without pain because, let's face it, pain is painful. But we humans actually need pain to protect our bodies from any physical harm. If a person were to put their hand under burning hot water, they would immediately jerk their hand back because of the pain they felt from the hot water. But if a person who can't feel pain were to put their hand under that hot water, they wouldn't feel a thing. So in the end, their hand could be burnt or even severely damaged. So pain actually helps us. Although it hurts, it gives us a warning signal that tells us to stop whatever we're doing, or else we could severely hurt ourselves.
This theory has also brought change in pain management with people who have chronic pain, which is long-term persistent pain. We can manage our pain by influencing only the large nerve fiber that carries the non-pain stimuli. Massaging, acupuncture, and electrical stimulation can do this. The theory also suggests to gain pain relief, distracting yourself with interesting activities will cause your brain to send messages through fibers that will minimize the transmission of pain signals. Overall, the gate control theory has greatly changed the ideas of pain and has helped many who suffer from chronic pain.